Okay, this is the exact problem that z-dawg and I are going to show you in lab form. So I'm going to do the math pretty quickly. We have a dilution problem. So we're going to go C1V1 is equal to C2V2. I'm going to write down what I know. Our C1, our initial concentration is our initial concentration is 0.1 moles per liter. Our final concentration is 0.0 moles per liter. And our final volume is 100 milliliters. So what we need to know is how much of that initial concentration do we use, and then how much of it are we going to be putting into our new flask. So if I rearrange this for V1, I get C2V2 over C1. So the whole idea of the solution is the whole idea of this, before I solve this, just real quick, is we have a solution that we made, and it has a concentration of 0.1 moles per liter. We're going to take a little bit of that chemical and put it into a second flask, and then fill it to the line of 100 milliliters, thus diluting it. But the volume that we need initially, we need to figure that out. How much of it do we need to add? That's why I'm solving for V1. When I read this problem, it gives me the C1, it gives me what we're diluting it to, and it gives me the concentration that we're diluting it to. So C2 is 0.01 moles per liter. The volume of the second system is 100 milliliters. The concentration of the first system is 0.1 moles per liter. So when I multiply that all out, I should get exactly 10 milliliters. So what that means is we are going to take 10 milliliters from our original solution, and we're going to put that in an empty flask. Remember, these volumetric flasks only measure 100 milliliters. So we're going to take that 10 milliliters there, put it in the flask, and then we're going to put about 90 milliliters of distilled water to dilute that to the line. That changes it from a concentration of 0.1 to 0.01. And you're in for a treat, because z-dawg and I are going to show you how that's done